Hey everyone, and thanks so much for attending today. This is our webinar with Josh Ironberg, Director of Engineering at Datalot. A few points of order before we start. First, I'm Arjun Narayan with Materialize. You can join the Slack, the community Slack at that link, which I will be monitoring, and a few other folks will be helping me from the Materialize team to triage, and I can raise your questions interactively, so please don't be shy. You can also use the Slack chat as well. At the end of this, a recording and additional resources will be shared as well, so don't feel obligated to take notes. And a reminder that anyone can install and run Materialize right at that link. And with that, let's kick it off. So as introductions, with me today, I have Josh Arenberg, Director of Data Engineering at Datalot, and I am the CEO and co-founder of Materialize. Today, we're going to be talking to you. Largely, Josh is going to be doing the talking, and I will help raise any questions that are shared. And we're going to try and keep this interactive if folks have any thoughts or questions on the content that is being presented. All right, so with that, a brief introduction on Josh. Josh has 2 decades of experience in big data, streaming, has worked with a lot of different architectures over the years. He has experience with real-time infrastructure, batch infrastructure, really crossing the full range of experiences with analytics, with production, and really has been at the forefront of looking at modern architectures and brings a perspective with a lot of experience with mature architectures in both the batch and streaming space. We will have time towards the end for some question and answers. But before that, let's get quickly started with a brief introduction on Datalot and their data challenges. And with that, I'll hand it over to you, Josh. Josh, you are muted.
That should be better.
Happens to all of us.
Sorry about that. Arjun, thank you so much for the great introduction and for the opportunity to be here and talk today. We've had a chance to work together a bit over the last year, and it's really been a pleasure and a highlight. So I'm pleased to be able to do this today. So thank you very much. So quickly about me, as Arjun said, I've been in an engineer or an engineering manager for about 20 years now. For the last 5, really focused on data, and especially distributed data, which sort of ties into the work before that, where I spent I did a number of years working on sort of grid computing and then virtualization and different distributed computing problems, and so it was sort of a natural move as things moved into distributed computing problems, moved into the data space with things like Hadoop and Spark, and I sort of went with it at that point. Prior to Datalot, I spent a couple of years at a cybersecurity startup called Blue Voyant, where we were looking at big data sets of trying to do things like threat detection and finding bad actors on the internet, and that was a mix of sort of batch data and streaming data. And then starting about 2 years ago, I hooked up with Datalot, and I came on as their director of engineering and running the data engineering program there. So a couple quick notes about Datalot, just who we are and what we do. We provide marketing and advertising services to the insurance industry, and this was something that was pretty new to me when I started a couple of years ago. I hadn't done anything in the ad tech space before, and or in the marketing space, and so as I started to talk to Datalot, there were a couple of things that I thought were really interesting about the company. One is just that it's a small operation. It's about 24 engineers, and been around at that point, had been around for a little over 10 years, and doing providing what is obviously just a very needed service to the insurance industry. As it turns out, a lot of insurance companies are not that interested in doing their own online marketing, online and especially so providing both sort of on the front end services to finding people that are interested in getting insurance, and then on the back end really running a marketplace to connect those customers with insurance agents, insurance companies, and lots of times that takes the form of a person that's live on the call at the time. So when I heard that, I thought, well, this is both a very data driven problem, and it's also a very time sensitive problem, it sounds like, and indeed one that is really where there's a lot of good applications for some of the new streaming data techniques. And so when I started a couple of years ago, really data engineering wasn't a separate discipline at Datalot. Everybody, all the engineers did a bit of data engineering, and it was, they'd sort of grown to the point where they were ready to say, okay, we're ready to have some folks that are just specialized on data, just looking at, the problems of getting timely data to the analysts, getting timely data to the customers, the front end customers, to the internal business customers, and really focus on modernizing some of the techniques that we're using, some of the platforms. And so that's really been where we're trying to go, and we're still growing. So this is some, we'll talk about this some more, but I think there's a lot of opportunity for growth in this space. So with that as an intro, I think we'll, next I want to move on to just talking a little bit just about the story of Datalot. What were the challenges that we had with data, and how did we sort of approach finding a solution that was right for the company, and how did that hook up with Materialize? And then from there, I want to kind of move on to the part that I'm really looking forward to, which is the boxes and arrows part of the presentation, where we get to kind of talk a little bit about some of the different architectures that Materialize has helped us to build, and I think maybe can help to give some context as far as like, where does Materialize fit in to to the picture with in a modern data architecture. So I think one of the first things when I came in was that I realized was that timely data is really vital to what Datalot does, and to what a lot of these analytics driven companies do. I think we're both, in terms of how on the front end, in terms of how we're running the advertising operations, in terms of how we are figuring out how our various campaigns are doing, but also on the back end in terms of monitoring our clients' performance and giving them tools to see how they're doing, real-time dashboards and things like that. There's just a lot of opportunity to make a difference with timely data. I think up until up to that point, and for 10 years, really, Datalot had been doing a great job of really pushing a lot of analytics just on a standard MySQL database architecture. And I don't want to downplay the power of that at all, especially as they sort of move, at a point they moved into the AWS Aurora stack with the database, which really did an amazing job of scaling with the business, and really they're really pushing that platform to do quite a lot. And so in some ways it was it really was a testament to how far things have come in terms of what you can do just on top of your transactional database. But that said, there were a couple real opportunities for improvement, and I think one big one was, I think a lot of it was around timeliness, right? The first thing being the timeliness of the refresh of the data. So for the analytics, for the main metrics that we're running the business, how quickly can we update those things? How up to date can we get those numbers that we're giving to the business and that we're putting into the reports? That's one thing. I think the next level of timeliness to think about is not just, hey, how fresh are the numbers in the report, but like, is the person who needs to be paying attention to the data, what's the latency between the report updating and that person knowing what's going on? So really having the data pushed to the people that need to know about it, rather than sitting static in a report or sitting on a dashboard that they may or may not be looking at when they need to. And then I think the third element of timeliness that was so critical was how long it takes us to build a new report. Like how are we structuring and presenting our analytic data in a way that can easily be used, to build new reports all the time, to be answering the new questions. And so sort of 3 levels of improvements that we wanted to see in the platform. So sort of the first thing that I did when I came in was start to build a real-time pipeline. And so, for those that are familiar with the concept of CDC, or change data capture, this was the first thing that we started doing, was how can we get the change events from the database and get them into Kafka, get them into a message bus where we can start to react to these events. And so the first thing that we did was we set up Debezium as a change data capture solution and a Kafka cluster to capture those messages, and then started sort of an ingest pipeline into Snowflake. And this was something that we sort of built ourselves. And so I think we got to the point where Snowflake was, 3 to 5 minutes behind production in terms of the data freshness, which was a big upgrade from, the overnight ETL that they'd been doing before then. But also, all of a sudden Snowflake became this platform where we really could not only do sort of long-term reporting, but really intraday reporting. We could give it to people to look at and really get fresh numbers from that platform. I think that answered a couple of I think it sort of got us halfway there, right? It got the data, the timeliness of the data story got much better, but the piece about bringing the data to the person, like how can we push this data out of the data warehouse platform into the application, or letting people know when literally when they needed to pay attention to it. This was something that was still an opportunity that was out there. And as I started to take a look at this space, I know I'd done some previous work with streaming platforms, and typically this is where a streaming data platform would really come in. And we looked at some of the existing solutions in the marketplace. We did some POCs with some various things, and really the reality of the situation kind of came into focus, that most of the stuff that was out there either required having a full team of Java or Scala developers on site to maintain your analytics and to create the analytics, or there were a couple of sort of SQL based solutions that we looked at that just that were nice and did a few of the things that we wanted to do, but really what we wanted to do was really replicate our analytic views that we had going in Snowflake and that we had going in MySQL in the stream, and have those views updating. And we're talking about a data set that is very relational in nature, very fully normalized. So producing some of these business metrics that had become sort of the bread and butter of the business and the things that they really wanted to see day to day required just joining lots of tables together. I mean, really, it was a matter of, it was just too complex for building in a lot of streaming data platforms. And this was sort of when I met Materialize. I actually, this was sort of when they had just sort of dropped their initial code, and I ended up Arjun and I ended up having a cup of coffee. I think it was probably what would you say, a week before things started shutting down for COVID, something like this. And so
we were all, what I do remember is we were hesitating on whether it was okay to shake hands. So it was
that's right.
already
Yeah.
nervous
Yeah.
time.
So definitely, yeah, you've got the timeline. And And so we started talking about this, and like immediately we started a POC, and we're very quickly able to build some of our existing reporting in Materialize. And so I think the way that I've come to explain how Materialize fits into the architecture in the easiest way possible is just to say it's a SQL query that always runs. So if you think about it, rather than writing SQL, passing it to the server, and getting an answer back for a single point in time, you pass the SQL query to the server hangs onto it and continues to write updates to the results. And so you get this changing result set that you can either, and it's maintained in memory, it's incrementally maintained on the server. So you can, with very low latency, get the answer back for that query, or you can have it actually stream out those results. So whenever the data set changes, it's sending a message, hey, there was an update to this row, there was a deletion at this row, these sorts of things, right?
So I wanted to dig in a little bit, Josh, with one question, which
Sure.
is, you've alluded to it here with institutional knowledge and SQL can be preserved. And can you go into a little bit of detail as to the complexity of these SQL queries that you are maintaining in real time? Because you came into this with a very sophisticated set of business logic
Right.
that you had going on in your batch analytics stack that contained a lot of value to the business that you wanted in real time.
Yes, yeah, no, that's a great point. And like I think one of the first things that I said to you when we first met is, we basically have this, sitting in Kafka, we've got, more than 10 years worth of business history that we're running analytics against already. And so, a lot of this stuff were very mature reports, 8-way joins, 10-way joins, a lot of, and especially since a lot of the reporting was built on top of it was either built on top of the transactional data model, or it was using some sorts of summary tables that were running on some sort of periodic business basis to update a summary view that was used for the reporting. But we didn't want to obviously build on top of those summary views. So we were actually going back to the raw transactional data model and rebuilding that summary logic, but in a streaming manner. And so that was sort of how we approached it. And so I think we chose some pretty challenging. We chose a couple of POC queries that probably had 10-way joins and a lot of a bunch of and one, a couple of things about Materialize that were immediately obvious was its ability to handle joins, and its ability to handle normalized data like that was far beyond any of the other things that we'd looked at. And then the second thing was, it had this feature of correctness in terms of points in time. So the framework that it's built on top of, which is timely data flow, although Materialize at the time was a brand new, timely data flow had been around for a while and was actually quite mature, and it provided guarantees for us about that there may be, depending on the complexity of what you're doing, there may be different amounts of latency in the calculation, but it was never going to emit an answer that was incorrect for any point in time. So even if you're joining 10 different streams up, none of the streams would advance until the other streams were ready for a particular point in time. And if you've done any work on streaming data, you realize what an important feature that is, because otherwise you can just get incorrect results if one of your streams gets ahead of the other one and there's nothing checking the time that the joins all line up. You can really get yourself into trouble. And with Materialize, it's just not something we have to think about, which is great. So that's essentially the story of how we got started with Materialize. And I think if there's no more questions about that section, I'd like to move on to taking a look at some of the architectures that we've built with Materialize and how they how they sort of fit in.
We do have one question in the chat,
Sure.
and I'll get to that. I think it fits better with the next section, so I think I'll raise it at the appropriate time.
Great.
Thank you for the question.
Sure. So the first one I want to look at, and I think this is probably uh, the simplest version, and actually this should read streaming ELT. I'm sorry. I think the title might have gotten messed up on this, but this pattern, extract, load, and transform, is familiar to folks that have done a lot of that have done work on sort of the modern cloud data warehouses. This is the idea that we load data into the platform and then manipulate it in place. This is probably the simplest architecture that we use with Materialize, but also super powerful. So the first part of this is the ingestion piece, and as you can see here, I tried to kind of highlight the different sources that sort of feed our Kafka streams. And the biggest one, the most important one, obviously, is our change data capture source, which is the Debezium connector. But then, we also have a series of batch collections, data that's sitting in external systems, maybe third-party data sets, or service platforms that we use that we're pulling in data on a regular basis. And so we have Airflow pushing those into Kafka. We have a service called the Strimzi Kafka Bridge, which gives us a RESTful endpoint into Kafka for that sort of places where the application wants to publish directly into Kafka rather than going through a database. And then recently we started messing around with some CDC connections to DynamoDB, where we're using that, as well as using S3 as an intermediary for like log data and that sort of thing. So one thing that became obvious pretty quickly with something like Materialize is that because there's so much flexibility on where you can ingest data from, it can become a point where you can really build analytics across sort of different data sets, across different data stores where you might have data sitting outside of the organization and looking for a place to kind of pull that stuff together. It tends to work well for that. Taking a look at a little bit at how the internally the logic works in Materialize, we've sort of taken an approach where we'll sort of build several sets of several layers of query to get to the ultimate to the report view that we're looking for a particular thing. So we start with a staging table, and typically the staging tables will sort of match one-to-one with the data source. So the staging table is where we do sort of the ingestion of the data into Materialize. We'll cast all of the fields in, and typically most of our data sources are in Avro. So we're getting nice like typed data with schemas, and Materialize just handles it. It actually has a Debezium envelope, so it can understand data in that format without us having to do any, like actually write any ingestion schemas or anything like that, which is great. But so usually in the staging table, we'll cast all the fields. That's where, and it will sort of match one-to-one with the source. So there's sort of one place, one table where data comes into Materialize, and then those staging tables will connect to multiple different data marts from there. The staging tables also, sometimes we'll, if there's a derived column that we use like across different reports, we might put it in there as well. And then the data mart, which is sort of like, I would call that sort of our analytic schema. That's like how we, and so from the staging tables schema kind of matches our transactional schema from MySQL in a lot of cases, because it's matching the source. The data mart is where we sort of stitch it together into a view that looks like something we'd want to build multiple analytics off of. Typically much fewer number of tables, wider tables. So we're joining a lot of stuff together lots of times in those data marts, organizing the data to make it easy to report on and that sort of thing. And then lastly, usually with this pattern, we'll actually build the report view in Materialize, and that's for a couple of reasons. And if you this is actually an interesting point because, with Materialize, you actually, the way that your BI tools interact with Materialize is very much as if it was just talking to a Postgres database. So your BI tool, you can put complexity into that query. Your mode query, your looker query, whatever, can have it can have complexity to it, and Materialize can return it. But oftentimes it's much more efficient to actually put the report logic into the materialized view. And what that lets Materialize do is incrementally maintain that view so that when your BI tool goes to look it up, it's really just like a cache lookup. It's pulling it straight from memory, and it's, milliseconds to pull that view back. So depending on, the different considerations, we tend to put as much logic as we can into the Materialize view. So the next architecture I want to look at is, let's see, this is the actual ETL view here, and this is, very similar to in function to the last architecture, but with the main difference being here that we're sort of using Materialize as the transform layer rather than the layer that's actually serving up the data. And this, for us, has been useful for things where we have very large data sets. Obviously, Materialize, at this particular point in time, it's maintaining all of its data in memory. And so if we had a big historical data set or something where we want to be sort of incrementally computing updates to that data set and then, doing big batch queries, or where we need to be able to extend compute or extend disk to support the query, like Snowflake has been a very good platform for that for us. And so, with this, you'll notice a couple of things. The ingestion piece looks the same, but where it changes is the Materialize queries just build up as far as the data mart. So you're not actually running the report view in here, but instead you're pushing the data mart in Avro format back into Kafka, so onto another Kafka topic, and then we're sort of ingesting that into our Snowflake pipeline. That way, we can serve bigger data sets. And I think this is, this may be something that in the future, as Materialize, the Materialize story matures around persistence, and they begin to, be able to hold stuff on disk. This model may go down in importance, but at least for right now, it gives us a really good way to use Materialize as the sort of the transform layer in a large ETL pattern.
So this is a good time, I think, to raise questions around input data quality. So we have a couple questions from a couple of different participants on duplicate messages, for instance, upstream of Materialize. And this sort of ties into questions of data cleaning and when you do have, so say, change data capture data that isn't quite at the best fidelity for correctness. How do you handle that? How has Materialize, in your experience, dealt with issues of, say, data duplication?
Yeah, that's a great question, and definitely something that we've dealt with, mostly because we do have such a large data set, and the challenges around sort of building building a CDC solution around that. And so, this is something, and I think what you're alluding to here, especially around Debezium, like, doesn't give you an exactly once guarantee. It gives you a at least once guarantee, which means that there are certain failure scenarios where Debezium will fail and then reproduce records, and you wind up with duplicates. This was something, and especially, the thing that's crazy with Debezium is, like, really, when you're learning about the system, when you're first standing it up, is also the most important time. So, because of that, as we were sort of figuring out, we run everything on, we were also coming up on Kubernetes around the same time. So we were learning Kubernetes and Kafka and Debezium all together. And so we wound, if you wind up in situations where, Debezium is running out of memory or something like that, you often see these failures where you wind up with duplicate records in the stream, and it's very hard to correct later. And so this is something that, we went through a few different iterations with Materialize on, but we landed on a model that they call Debezium upsert, which does sort of the semantics look like it's looking at the key and it's keeping track of basically Materialize internally is keeping track of the last message for the key. So what that allows us to do is a couple of important things. One is obviously it allows for deduplication. Like a duplicate record is not going to break the data set. And secondly, it allows us, some of our but before that upsert method was available, I think a typical ingestion for us could be over 3 terabytes, 4 terabytes worth of data that we had to transfer from Kafka into Materialize just to get to our fully hydrated system. At this point, so once Upsert was introduced, it also gave us the ability to sort of start in the middle of a Kafka topic. So because we could do things like say, okay, for our dimension tables, maybe we need the whole topic, but maybe for our fact tables, we're only interested in keeping 6 months worth of data in Materialize rather than 10 years. Like we can just go back 6 months in the Kafka topic and read in from there. And it's not going to break Materialize because it's able to understand those upsert semantics. So that was very important for us. And I think, it kind of, where in the early days, it was taking us multiple hours to do ingestion. I think the last production, we do a blue-green production deployment every week. And I think they're running about 31 minutes right now. So which is great for us.
So that ties into the other question, another question from the chat as to when a node goes offline or when you restart nodes. I think I don't want to preempt you if you're going to talk about that blue-green deployment process that you have later on, but it is interesting to understand sort of the implications on restarts and updates and
Sure.
upgrades of the cluster, how you handle that.
Yeah, absolutely. And I do have a slide at the end where I sort of go into the prod and the dev environments, and maybe I can, when we get there, I can sort of fill in any gaps that I don't cover. But but essentially, yeah, I think it's an important consideration. Something we worked on a lot is how our deployment pipeline works and how we're doing the blue-green deploy. So I'm happy to talk about that.
Excellent. So we'll talk about that at the end.
Yeah.
Another question we have is around respecting transactionality of the input when joining across multiple tables. Right. Using the Debezium envelope and whether there've been any challenges with that and how you how do you get the correctness guarantee out?
Yeah, I mean, it's not like the way that our data set is, we don't have a lot of complex transactions. So it hasn't really been a huge problem for us just because of the nature of our data set. But, I know it's not I know with Debezium, it's not perfect the way that it handles transactions. But I believe I may not be the best one to answer that question, to be perfectly honest, because it's not something that we've had to focus on too much. But Arjun, I think it seems like where there's shortcomings there, some of that is around how Debezium reports on the transactions.
Yeah, I do want to make sure that we're keeping the talk on track. So there's another question, for instance, around sort of Materialize scalability. I'm happy for you to answer your perspective as to how Materialize has scaled with your data set and how it's performed for your data set size. But I'm also to the attendee that asked the question, we're happy to talk at length in the Materialize Slack on sort of general scalability, and also continue the conversation around transactionality.
Yeah, I think for us, so far, our data sets tend to, I mean, I think we're sort of on one production Materialize server still, and I think we're on there's still plenty of larger sizes available in AWS to us. I think the focus has been around keeping things on one server for right now. I know there are possibilities with the platform as far as scaling horizontally are concerned, and whether that's via sharding the data set or whether that is actually, I believe there's plans in the future for Materialize to turn on functionality there. But you know, I think for us, we're still pretty far from needing to go beyond a single box, and that's been you know, because of the nature of it, because it's happening in memory, and you know, performance has been a critical thing. We've been happy to sort of keep it to that for now. But so let's see. I guess we'll move on to the next architecture, if that sounds good. So the next one, this is I think gets to some of what I was talking about before about pushing data to the users rather than, you know, surfacing data in a report or surfacing data in, you know, in a BI tool or something like that. This is like, I think pretty quickly we realized, you know, the potential here, because we have this streaming system that's able to reproduce these business critical metrics, and really, you know, when I came in, you know, especially in a company that been around for 10 years and is as analytically focused, like there was just a whole vocabulary around some of these analytical metrics that they had developed. You know, the way that they talked about the business, you know, they had terms for, you know, all sorts of different measures of the business that everybody just talks about, you know, the analytics team, the business teams, and a lot of those things were only able to be derived by passing this huge SQL query to the transactional database and then getting back, and that would happen, you know, periodically over the course of the day, which, you know, which worked fine, but it meant that there was no way to drive automation, to drive logic off of the changing of these metrics, these critical metrics. And so I think one of the things that we quickly realized is, like, with Materialize incrementally updating every time there's a change to the database, now all of a sudden these critical business metrics are updating. And so that means we can build thresholds around them. We can do things like, you know, we can look for particular changes that are happening in these metrics. We can look at, like, how the data is affecting the business, and use that as the source of events in the microservice architecture. So this is sort of the model here of using Materialize as the event source for, you know, event-driven services. And so, you know, this piece, again, the ingestion piece, works the same as the other models, but you'll notice now within Materialize, we're still oftentimes building off of those same data mart views that we're using for the reports, but then we're maybe doing an additional level of view that's pulling just the subset of data that's needed for the particular service. So, you know, we want, you know, maybe there's you know, maybe we're building a service to adjust a bid somewhere, and it just needs certain pieces of analytic data that it needs to take action. We can put that as, you know, into a Kafka topic, and then use any sort of Kafka-based, you know, event-driven microservice framework to build that service. We've, you know, being a big Python shop, we really liked Faust for this, and Faust is just it's a pretty simple microservice framework. It's built by the team at Robinhood, but it's very Pythonic. It uses Python async, which we like a lot. So it's like, for our use cases, plenty performant. Like, I mean, I could see, you know, some people where they really need performance critical stuff, maybe they're not using Python, but for most of our use cases, like building it on Python, building it on Python async is a good fit in terms of simplicity. We can spin up a new service very easily with this thing. It provides us tools also for maintaining sort of state within the service, and also for serving up results simply through like a RESTful endpoint. So, you know, these microservices can work one of two ways, right? It can be, you know, it can either, the service can kind of do its thing, and then it can publish results back into Kafka on another topic. And so you can sort of get this event-driven chain of microservices where you really get a pipeline kind of effect. Or if this is sort of a terminal service, like it does its thing, and then it's got its, you know, it's producing some kind of data that we want to serve up we can also just use that fast service as like as a RESTful endpoint, and to the outside world. But this pipeline, these events, for people that haven't done event-driven microservices before, there's like a few things that are really great about this versus like REST coordination of microservices. And I think like for us, one of the biggest ones is that they're really fault tolerant. Like if any piece of, if any services in your architecture go down for any reason, or if they die, like you don't have this big resynchronization problem across your service architecture, because they're all using this Kafka bus in the middle. So they can, if something fails, it can come back up, and it knows its offset. It knows where to pick up and how to catch up without having to, do some kind of manual resynchronization. And so this has been, it really adds a lot of simplicity to your operations to be able to build services this way. And then I think the insight with Materialize is like, we can, versus just building the service right off of Kafka, is that we can build it at a higher level of abstraction in terms of looking at the business metrics, rather than just, what's happening in this table in the database, what's happening in that table in the database. So, again, it all comes back to be able to like recreate these business metrics in the stream. And so the next couple that we're going to look at are sort of refinements of this event-driven model. The first one is looking at machine learning as as a special case of that microservice. And so this is something that we're just, as an organization, just kind of getting started with. But we've had already some pilots that have looked very promising with this architecture. And here we're, again, the Materialize piece looks very much the same. We're building off of the data mart, but, rather than, where you might actually, in machine learning parlance, you might call it an online feature store. This is like Materialize is providing the machine learning model with all of the dependent features that it needs to run. So to give you an example of how this might fit into our architecture, we've got all these consumer websites that are out there in the world, and we have people interacting with them, and we may want to run a machine learning model on someone who's interacting with one of our consumer sites, rather than having to build synchronization between the machine learning service and each individual version or each iteration of the site that we may have out there in the world. Every time we change the site, we're not having to plumb in the machine learning directly into the site code, because it's just happening just off of the database. So the way that it looks is, in Materialize, we write a query that basically says, hey, once we've received enough, we're building a view with the following dependent variables in it. And once someone has interacted with the site long enough that all of those views are populated, Materialize just emits that as a message, and that kicks off the machine learning service, and we immediately have that model running and the answer available. So it just becomes a really good, like a very convenient way to productionize a model that doesn't require us to change any of our front end at all. And again, with this, the output of this service can either go back into Kafka as a topic, or we can serve it up right from the service. So this is.
So Josh, we've had a few questions, and we're not going to be able to get to all the questions because we do have a lot of content to cover and not a lot of time remaining. A note that we will answer questions, and I will be there in the community Slack after this, and we'll hold questions that are a little bit general to that. Apologies for not answering them live. There's one question that I think it would be very valuable to have your perspective. So I'm going to raise it.
Sure.
And a participant asked, sort of, how do you choose when to put logic in Faust or in Materialize, and how do you come up with delineating that boundary?
Right. Yeah. No, that's a great question, and I think, the way I think it comes down to looking at the data model, looking at the data model of the object. So like in Materialize, you sort of have access to much more data. So really generally what I'm thinking about there is building a data object that contains um, all of the data that the service needs to take action. So in general, I'm usually trying to do as much as I can in Materialize. It's just easier. It's a SQL query. It's and rather than, you know, like if if at all possible, I'm trying to keep what's happening in the service to just reading one topic from Kafka. So Materialize is synthesizing all the data, boiling it down to the data object that, you know, in the last level of the view, creating just the object that the service needs to run. And then the service is, you know, sort of hopefully just subscribing to one topic and can use that message to take whatever external action it needs to take, whether it's, you know, running a scikit-learn model, or, you know, communicating with other services, or, you know, what alerting or whatever it needs to do. Yeah. Which is probably, you know, probably a good transition to the next pattern that we have, which is again a variation on this microservice model, and this is the alert service. And so I think this is something that we realized, you know, since Materialize actually has access to this changing data, uh, and it's always being incrementally updated. A very a logical extension of that is let's build let's 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 put some thresholds around that. Like, as a user, instead of looking at a dashboard all day, maybe I just want to say, hey, let me know if, you know, my revenue for my biggest client drops by more than 10% today, or let me know if you know, if the call center is like performing like you know, more than 20% below what we're used to, or you know, you can think of, you know, many examples of, you know, all of these business critical metrics that people are sitting there monitoring intraday. They're all good candidates for alerts. And so the way that we've instrumented that with Materialize is using a construct called a lateral join. For those that do a lot of SQL, you know, you'll be familiar with that pattern. For those that aren't, you know, it's forgivable. I hadn't written a lateral join before we before we built this, so it certainly uh, forgiven if you haven't heard of that before. But basically what the pattern looks like is that, you know, you've got you have an inner query that has a bunch of parameters in it, and then you have sort of an arguments table that is filling like sort of multiple sets of arguments for that interview. So you're iterating over a query, plugging in these sets of arguments. And so what that looks like in the alerting space is, you know, we have a user that's interacting with a UI where they're setting thresholds, they're setting filters, like, you know, there's a bunch of different filters and thresholds that you might set around when do you want something to alert, under what conditions, and that populates the arguments table. And then on the Materialize side, we've got this lateral join that's iterating all of the set alerts and checking them against these sort of data mart views of the data that contain, and actually emitting, what comes out of Materialize is basically, here's a list of all of everything that's in an alert state right now. That's what comes out for a particular alert view. So maybe we you know, maybe we have an alert view for, you know, for our accounts. And so there's like one view for accounts, and that, you know, a set of different thresholds that different people are interested in, for alerting on for the accounts view. And so a Materialize will emit a table of everything that's currently in an alert status, and that's what goes into Kafka. And then we've got an alert processing service which basically keeps track of our notification rules. Here's the people that want to know about it, here's the Slack channel they want it, here's the hours that they want to be notified in, here's the, you know, all of the nuts and bolts of how you'd want your alerting system to behave sits in that service. So that and it's just getting these messages of, hey, something new has gone into an alert state, or an alert, or something has been removed from an alert state. That's also something that we can take an action on. So we could say, send a clear, if we want to, we can say, send a message that something has gone out of an alert state, that sort of thing. And so right now, like, we're just launching this now, and the our alert service right now is basically interacting with Slack, but I think the plans are to have, a whole set of different alerting endpoints where, it could be anything from, SMS, email, in-app notifications, all kinds of different endpoints. But then the interesting thing is, when you really kind of stand back from this and squint, is you realize, like, this same exact system that right now is just generating alerts, this is what it's actually generating is business signals that you care about. So what we see this evolving into is, like, after a while of just using it to, hey, let me know when something that I care about is happening in the system. The next question is, what are you going to do about it? And let's automate that. So rather than this alert endpoint just being Slack, we want to be building a set of microservices that are, a whole range of everywhere from, like, an alert to a semi-automated action. Maybe like Slack is just saying, hey, we've got this condition, click here to do something about it, click here to raise your bid, click here to, like, change the, maybe, so like semi-automated actions all the way up into, like, full automation, where the system is just, like, seeing something go into alert status, kicking off another microservice to do something about it. And then so this is really a pattern that we're very excited about, and, like, using Materialize as sort of the place where we build these guardrails that sort of become the second level of automation for the business, not just automating on top of customer actions, but automating on top of, like, these analytic metrics that we're used to operating on as business.
If you'll indulge me for a second, Josh,
Sure.
this is really cool. And in particular, once you start taking these automated actions, is where we've seen concerns around consistency and correctness really kick it to another level, because eventual consistency can be fine when feeding like a real-time dashboard, because like a human can always sort of say, oh, that's just a false alarm. But once you start doing this, which is where the real value is, in my opinion, in real time, uh, that's when you can't have automated actions firing off of some false alarm, eventually consistent, incorrect result. I don't know if you've had some thoughts around sort of the consistency value, the value
Yeah,
of consistency.
it's really valuable that we don't have to think about it. It's nice that the platform, it sort of takes care of that whole set of problems, and it does it in a way where, I mean, we have people who are not necessarily streaming software developers working on this code. We have people in our analytics department. They just speak SQL all day long, and they're able to write this logic for us as SQL queries, and then it's very easy for us to adapt that to something that is driving a microservice, which is really neat. It gives us a whole different group of people, especially at a company as small as ours, right? I don't have a whole team of developers to build this stuff. I really need to lean on the analytics guys to build a lot of the logic that's driving this stuff. And so, uh, you know, we wouldn't be able to do it otherwise. Cool. So I think this was my oh, no, sorry. I have one more architecture, and this is a really cool one. So, this is sort of like the holy grail of the event-driven architectures, right? Which is fully event-driven from the database all the way through the front end. And I think, again, here, the ingestion piece looks very much the same as our other examples. We're building off the top of the data marts, building a view in Materialize to support a particular visualization. We're going to do a lot of this because we do lots of stuff. Like our main application, the Datalot application, is mostly like analytic charts and graphs. And so this is something where, surfacing these analytics into the app is really important to us. And this makes it really easy to do it in a way that updates in real time. You can update right all the way up to the UI. And one of the things that's coming soon in Materialize, by the way, that's going to help with this a lot is some of the features around windowed data. And so what it's going to allow us to do is build this terminal view, the visualization view that I've got here within Materialize, that is only holding on to, maybe some small time frame of data in that window. And so that I can, when it comes time to build the front end, you can build up your initial view when you first load the page based on exactly the amount of data that you want to populate. Say you want to build, maybe you want to build a graph, build a line graph that starts with 2 hours worth of data when you first load the page, builds the 2 hours into the graph, and then from there just keeps on ticking as like every time the database changes, it's publishing it all the way to the front end. And this is extremely easy to do with the Materialize view. It uses a protocol called Postgres tail. For those that haven't played with that in Postgres before, basically it looks a lot like a CDC view. It's change updates. It's change updates that are streaming. And there's a couple of ways that we've played with using this. One is, we use GraphQL a lot on the back end, so we've been working with instrumenting this as a GraphQL subscription that can talk directly to Materialize via Postgres tail, and that's something that we're working on internally. Or we've had worked with some of the Materialize folks built a WebSocket service that we can stand up, and basically it can pull that stuff as Postgres tail, turn it into a WebSocket, and then we can plug into that directly with JavaScript. So there's a couple different ways that we can achieve this. But we have some pretty successful prototypes. We don't have anything streaming in production yet to the front end, but we have some very successful prototypes, and we plan to go live with this pretty soon.
Just a quick point of order. We are at time. We're going to keep going for another 5 minutes. But for folks who need to drop to get to a meeting, we will be uploading a recording and slides so that you can catch up.
Great, and thanks for joining. So the last thing I thought it'd be, and I'll be quick here. I just thought it'd be maybe interesting to take a look at what our actual deployment architecture looks like really quickly, because this is something that we've sort of been figuring out as we go along here. And this is kind of it in brief. We use there's a set of open source operators for Kubernetes, for Kafka on Kubernetes, that we use called Strimzi, that we're using for a lot of our architecture that's really worked well here. So Strimzi is running most of our Kafka connectors on the ingress and egress side. It's also running our Mirror Maker 2 image. So if you see, we run a mirrored copy of our Kafka cluster, and that's proved very useful as both for development and staging, to keep it set, and so that we don't have to worry about people spinning up. Materialize is very efficient in the way that it consumes data, but it can, depending on how you have it configured, it can hit the Kafka cluster pretty hard if you're pulling a large data set into memory, mostly because it's just very fast, and so it pulls a lot of data really quick. So having a secondary Kafka cluster has proved very useful for us for this reason. And so I'm happy to answer any questions about how we're doing this. But we're making liberal use of spot instances on EC2 for Materialize development. It makes it very cheap to give someone a nice large machine that they can ingest lots of data into. It's only annoying when AWS decides to take it back from you in the middle of doing something important, but it's been a good trade-off for us. We also have a staging environment and a production environment that both run the same way. And right now we're doing weekly blue-green deployments. So we have a Jenkins job that stands up a brand new EC2 instance, loads all of our Materialize views onto it. Once those views have completely populated from Kafka, then it puts the Kafka syncs onto it and destroys the old view. and we're actually using the tool DBT for deploying all of our Materialize stuff, and that we could have a whole nother hour-long conversation about how we're using DBT. But I've done some really interesting work with Jessica Laughlin at Materialize and Amy Chen at DBT to kind of get that to a place where we use DBT as sort of our deployment solution for Materialize jobs, both in production and also sort of in the development cycle when you need to be like continually refreshing a view and Materialize. DBT can make it a lot easier to keep that process structured and make sure that you're really respecting the it can sort of sort out the dependency tree, because as you can see, you end up with lots of queries that depend on queries that depend on queries, and keeping all of that straight can get laborious. DBT really kind of makes that a non-issue. So happy to talk about that in the chat later as well. But that's about it for the architectures that I wanted to go over. One real quick thing that I'll say is we're hiring data engineers, and so we would love to hear from anybody, especially if you're investigating Materialize. I think you're the type of person that we would love to hear from. We're doing lots of stuff with cutting edge tools in the space, and we're a small enough company where you'll get to touch lots of things, everything from the infrastructure, playing with Kubernetes, playing with Kafka, to Debezium, up to the Materialize layer. You'll be writing services in, Faust, using things like Airflow, Snowflake, DBT, these types of things. So please come join us. It's a great place to work. We're located in Dumbo in Brooklyn, which is a great place to be, and we'd love to hear from you.
And we can attest from the Materialize side that we really enjoy working with the Datalot engineers. They are a great team. I missed one question. I apologize to Christopher for missing it. I just missed it as the chat was moving. This is for you, Josh. He asked if you have a recommended alerting framework for building and managing the alert logic, thresholds, frequencies, things like that.
I've been writing it. Yeah, to be honest, like again, I've just been implementing it in Faust, and which has been, but I think it would be an interesting, and it may be there's an existing open source project that does this type of thing. Wouldn't surprise me at all. But if not, it'd be a great open source project to build like a generic alerting framework for Kafka based, because this is definitely a reproducible pattern.
I guess I can sort of speak to another customer that enjoys that has built both their visualization on Metabase as well as their alerting on Metabase as well. So I there's obviously many frameworks here that can work.
Yeah, I'd love to hear more about that. That sounds really interesting. Cool. Any other questions or?
No, sorry, that was just the one that I'd missed.
Awesome. All right. Arjun, I think this is where you pick it up.
Well, thank you so much, Josh. This is a really, really good conversation. We went well over time, and I do apologize for the few questions that we didn't get to. Thanks to all the attendees. Thank you so much. You can use Materialize today either by just downloading it, or you could sign up for early access to our cloud product, which is live today. If you sign up, you get access to fully managed Materialize instances and a web UI. You can spin up additional instances in less than 30 seconds. Currently, the cloud beta is AWS only, but we have plans to take this to other clouds as well. For now, it is in AWS. And thank you so much for attending. We really appreciate all of your questions. And again, we will be in the Materialize Slack to answer follow-up questions. Thank you very much. And thank you so much, Josh, for presenting today. We really enjoy working with you. Yeah. And we enjoy chatting with you as well.
Thanks again, Arjun. This was great.
Thank you.